Hello and welcome students and family members. This is Mr. Panza as we are reviewing algebra. Our algebra test is coming up and we've applied, studied, and utilized many algebraic thinking concepts over the last week or so, and now we're going to have a cumulative review to get ready for our test. Let's take a look at the first couple of questions. First few are multiple choice. So we have choices A, B, C, and D. I'm going to remind students as I go through each problem which strategies we discussed throughout the unit so that they can solve each problem. In the first one, we have an input-output box, and we're looking for the number that goes in the blank box, which in this case is right here. Well, the one thing I told the students to do is each time they have an input-output box, they need to actually create a third box. The reason they need a third box is because each input and output has a specific rule that applies to everything. So in this case, it's in, R, out. That R, of course, means rule. Try and determine what the rule is. Typically, you can use algebra to determine what the rule is and then apply the rule every single time. So for example, if I wanted to use algebra, I need to see if I start at 4 and I increase my number to 20, I'm either adding or multiplying. Well, if you're like me, you like to try the simplest mathematical equation first. I'm going to try and add. I just don't know exactly what I'm adding. So now I have an algebraic equation. I take what I know, the 20 and the 4, and I create an open number sentence. 20, because it's an addition problem, needs to be subtracted by 4. 20 minus 4 would be 16. So it's potentially plus 16 as a rule. What you can then do is try it out with the very next one and see if it works. If I take 5 and I add 16, what do I get? 17, 18, 19, 20, 21. Is the output 21? Absolutely it is. Try it out with number 9, plus 16. So I have my plus 16 as my rule, and I should get 25. So if I add 10 to 16, that would be 26 minus 1 because it's 9 makes it 25. So now I can say with positivity that my rule is plus 16, which means when I take 12, I need to add 16 more. And when I add 16 to 12, I'm going to get 28, which in this case is choice C. So even though the input-output box is already set up for you, make sure that you are setting up a separate input-output box off to the side or on a separate piece of paper where you can determine the rule using algebraic thinking. On to number 2. Another algebra problem, except this time you need to know, are we adding, subtracting, multiplying, or dividing? 17 blank 6 equals 102. Well, the great thing about the algebra test is we can use our calculator. And in this case, because it's multiple choice, you can test each one and see which one works. So if I did 17 plus 6, it does not equal 102. I know that the number is increasing, so it cannot be B. So I'm going to try the next choice, which in this case is multiplication. 17 times 6 equals 102. So after I tested them out, I know that it's multiplication, and again, choice C is the correct response. Here's a number sentence. It's open because I have a missing section right here. Now, the students also learned during this unit that this missing section could be filled in with a question mark or a variable, such as the letter A. Any variable will work. In that case, because it's an open number sentence, I can use basic algebra concepts to solve for the question mark or variable. Take what I know, 54 and the 17, and apply the opposite operation than they are telling you to do addition. So in this case, you need to do 54 minus 17. Now again, the reason you're allowed to use calculator on this test is because I'm testing you on your algebra thought process. I'm not testing to see if you can subtract or not. So in this case, when I subtract 17, I get 37, and my answer checks out to be B. Using algebra to solve an open number sentence works every time. You just have to know the rules. Flip it to page 2. Question 4 is also multiple choice, and again, we're dealing with number sentences. We need to find the number sentence that matches this word problem right here. How many apples are in a package if there are 7 packages and 56 apples in all? All of the packages have the same number in them. So which of these is going to equal the correct response? When given a word problem, I encourage the students to read through each part and start to write a number sentence so that they can solve these types of problems. So in this case, we're trying to determine if there are 7 packages and 56 apples in all. I have my total. How did we get to 56? We know that there's some sort of variable here. So in order to get to 56, they either increased by adding or increased by multiplying. And in this case, because there are 56 in all, I would be able to multiply because my algebra equation would be able to solve for x. You don't have to solve for this one, but just in case you wanted to, you would take what you know and do the opposite operation of multiplication, which is division, to solve for x. So in this case, 7 times x equals 56, which in this choice is choice B. Number 5 is another number sentence. You need to match the number that makes this sentence true. Well, use your algebraic thinking. Take what you know, the 32 and the 8, and try and fill in for this variable, this question mark, the unknown. How do you do that? You normally do the opposite operation, but with this division, you actually are going to divide. So take 32 and divide it by 8. And that's going to get you 4. Now, we also told the students that with open number sentences, you should always be able to check. So after you solve it, over here on the side, check your response and see if you're correct. Replace the variable question mark with exactly what you thought the answer was, in this case 4, and see if it equals 8. So I'm going to take 32, divide it by 4, and I get 8. This problem checks out. Every single open number sentence can check out as long as you apply whatever you believe that variable is to the actual equation. Number 6 is another input-output box. Which expression could be used to figure out the empty space? First, I've got to find the rule. And again, off on the side, what is this input-output box missing? The rule box. So if I have the in and the out, find the r, or the rule. If I start with 3 and I go to 9, I'm either adding or multiplying. Let's try addition first. If I add, I know that it's adding something equals 9. And to solve for this variable, I need to take what I know, the 9 and the 3, and do the opposite operation. 9 minus 3 gets me 6. Does plus 6 work for 6 to 18, however? It does not. So in this case, I'm not allowed to add. I actually have to change it then to multiplication. And once again, use your algebraic thinking to determine 3 times what is going to get me 9. If you take what you know, your 9 and your 3, and you do the opposite operation, in this case you divide, 3 going into 9, you'd get the question mark, or 3, and in this case, the rule, which is multiply by 3. So I'd have to take 10, and I multiply it by 3, and which expression would actually work? X times 3. Because in this case, the x would represent this number here to determine what the actual rule is. Here are a couple number patterns that we've been taught a specific strategy how to solve. If I'm looking for the missing numbers, I first have to determine the rule. In case you forget, the first step is to draw carets between each number. Then you need to determine, using algebra, what the rule is. So in this case, I go from 170 to 181. So I'm increasing, and I'm not multiplying. I just don't know what I'm increasing by. So 107 plus x equals 181. I need to again take what I know, do the opposite operation, or 181 minus 170, to determine what the rule is. 181 minus 170, and the rule is not just 11, but it's plus 11. I'm going to put that right here, and at this point you need to apply plus 11 to every single one. So for example, 192 plus 11 is going to be 203. And you do the same thing with these final 2 lines. What's the rule? Plus 11. to solve. What's the rule? Plus 11, and solve. How about the pattern when they actually give you the rule? Well, in this case, you can draw your carets, but you don't even have to determine what the rule is, which makes this step a little bit easier. 21, we know we need to add 7 to determine what's on this line, which in this case is 28. What do we have to do to the next one? Add 7 yet again. And in this case, I get 35. Notice the pattern here as well is skip counting by 7s. 21, 28, 35, 42. You're adding 7 each time, which was the rule, to determine what was on these two blank lines. Flip it to page 3. Continuing with short answers, I have what looks like an input-output box, which is similar, but a little bit different because I have the word problem here. In orange, Dan sells, buys bags. If Mr. Pan's is buying 4 bags, how many oranges would he be buying? I need to determine the rule here. If 1 bag contains 8 and 2 bags contain 16, if you haven't noticed already, the pattern here is actually off to the side. I also told the students to start looking for patterns not just in the middle, not just in the rules, because in a question like this, you'll be able to determine those patterns on the side and come up with your answer. If you were looking for total number of bags, well, the rule here is increase by 1. However, we're looking for total number of oranges if you bought 4 bags. So notice that we start at 8, 16, 24. Each time we're increasing by 8, which means if I bought 4 bags of oranges, I would have a total of 32 oranges. In a similar fashion, in problem number 10, Mrs. Riley keeping track of her push-ups, we need to find the pattern to figure out exactly how many push-ups she did on Wednesday. Well, in this case, it's a number pattern problem. So take your caret and connect it to the next step and use algebra to determine what the rule is. If I'm increasing and it's not multiplication, it has to be addition. 200 plus some variable, let's call it A, equals 230. Again, in algebra, I need to take what I know, the 200 and the 230, and do the opposite operation, which in this case, the opposite of addition would be subtraction, to solve for my answer, which tells me, when I subtract, that my rule is plus 30. So when I do 230 plus 30 more, I'm going to get 260 sit-ups, or in this case, push-ups, on Wednesday. You have to notice the difference between number patterns and rules. However, you can solve for each of them the same exact way. Numbers 11 and 12, I have function tables. Once again, I'm encouraging all of the students to not just take these function tables for as they are. Please complete the function table that I'm creating below to make sure that you're showing mastery in this case, which means you need to add the rule in the middle. Input, rule, output to both number 11 and number 12. Once you've determined the rule, you'll be able to solve for this blank box by using algebra and this blank box by using algebra yet again. Here's how. If I start with 4 and I'm at 20, I know I'm increasing. It's just a matter of asking myself, am I adding or am I multiplying? Let's try adding first. 4 plus something will equal 20. So in this case, I take the 20, I subtract 4, and I find out that the rule is add 16. Does that work for 8? No, because when I take 8 and I add 16, I get 24, not 40, which means I'm most likely multiplying in this case. Let me go ahead and check that rule out. 4 times a variable will get me 20. So in order to solve for this variable, this question mark, I take the numbers that I know, the 20 and the 4, and I do the opposite operation. 20 divided by 4. That's going to solve for x. And when I plug that into my calculator, I get what x equals, which is 5. I believe then the rule, in this case, is multiply by 5. Try it out. 8 times 5, does it equal 40? Yes, absolutely. So in this case, apply the rule to the third and final number, 12, multiply it by 5 to get the output. Do the same thing for number 12. Determine if you're adding or if you're multiplying, and then apply that rule to solve for 8. But you have to do that by creating a brand new input-output box that includes the rule box right in the middle. Let's flip it to our final page.